Good morning to all. Welcome to video lecture. A course material on AI 3403 Strength of Materials for Agricultural Engineering. Presented by R. Rajiv Gandhi, Assistant Professor, Department of Civil Agricultural Engineering, Rohini College of Engineering and Technology. This is Unit 1. Let me discuss about analysis of bars of composite sections. A bar made up of two or more bars of equal length but of different materials rigidly fixed with each other and behaving as one unit for extension or contraction when subject to an axial tensile or compressive load is called as composite bar. For the composite bar, the following 2 points are important. The extension or contraction in each bar is equal. Hence, deformation per unit length strain in each bar is equal. The total external load on the composite bar is equal to the sum of the loads carried by each differential material. Stress, strain and deformation of solids. The figure shown as a composite bar made up of two different materials, that is number 1 and number 2. Let P is equal to total load on the composite bar, L is equal to length of the composite bar, A1 area of cross section, A2 area of cross section of bar 2, E1 Young's modulus of bar 1, E2 Young's modulus of bar 2, then P1 load shared by bar 1, P2 load shared by bar 2, sigma 1 stress induced in bar 1 and sigma 2 stress induced in bar 2. Then one example, a steel rod of 3 cm diameter is enclosed centrally in a hollow copper tube of external diameter 5 cm and internal diameter of 4 cm. The composite bar is then subjected to an axial pull of 45 kN. If the length of each bar is equal to 15 cm, determine the stress in the rod and tube. Second one, load carried by each bar. Take E for steel 2.1 in 10 to the power 5 Newton per mm squared, and for copper E 1.1 in 10 to the power 5 Newton per mm square. Then given data, dia of steel DS 3 cm, dia of copper DC 5 cm, small diameter of copper DC 4 cm. Load P is equal to 45 kN, L is equal to 15 cm. Then Young's modulus steel is equal to 2.1 in 10 to the power 5 Newton per mm squared. Young's modulus copper is equal to 1.1 in 10 to the power 5 Newton per mm square. To find the stress in the rod and tube. Second one, load carried by each bar. Solution. Area of steel rod. Area of steel rod, area of steel is equal to pi d square by 4. Therefore, substitute the values pi into d 30, so 30 square divided by 4. Therefore, we got the area of steel 706.86 mm square. Area of copper, the tube. Therefore, that is the inner dimension and outer dimensions available. So, 5 by 4 into capital D square minus small d square. There is copper. Okay, substitute the values 5 by 4. Capital D is equal to 50 square. Small d is equal to minus 40 square. Then 706.86 mm square. The stress in the rod and tube, we know that strain in steel is equal to strain in copper. Sigma S is equal to sigma C. Young's modulus S is equal to Young's modulus C also. Therefore, find the stress sigma S is equal to sigma C. Therefore, S is equal to 2.1 into 10 to the power 5 divided by 1.1 into 10 to the power 5 into sigma C. Therefore, 1.909 sigma C. Then stress is equal to load by area. Therefore, load is equal to stress into area. Load on steel plus load on copper is equal to total load. Sigma S plus AS plus sigma C into AC is equal to total load. 1.909 sigma C into 706.86 plus sigma C into 706.86 is equal to 45,000. Then we simplified, sigma C is common, sigma C into 1.909 into 706.86 plus 706.86 equal to 45,000. Therefore, we got sigma C 2056.25 sigma C is equal to 45,000. Then let me get sigma C is equal to 45,000 divided by 2056.25. We got the value 21.88 Newton per mm squared. Substituting the value of sigma C in equation 1, we get sigma S is equal to 1.909 into 21.88. Therefore, 41.77 Newton per mm square. Load carried by each bar. Load is equal to stress center area. Load carried by steel rod PS is equal to sigma S into AS. Substitute the values for sigma S is equal to 41.77 and AS equal to 706.86. Therefore, 20 therefore 29,525.5 Newton. Then load carried by copper tube PC is equal to P minus PS. Total load P is equal to 45,000. Load for steel is equal to 29,525.5. Therefore, we got the copper value 15,474.5 Newton. Thank you.